All right, so far we have learned how to factor quadratic polynomials. We've done some greatest common factors. You can kind of see here I have this flow chart, so you should have this printed out. If you don't have it yet, go ahead and ask for one. This is the factoring flow chart, and it's going to be your lifesaver over the next couple weeks. So notice we always start out with a polynomial. No matter what, you have to take out the GCF first. So if all of the terms divide by 2, or if all of the terms have an x, you need to factor that out front. Then what remains is what we look at to factor the rest of the way. So we've already talked about bottoms up before. We reviewed that earlier this year. You should be able to do an A times C bottoms up. What we're going to learn about next is what to do if a polynomial has 4 terms. So you can see if it has 4 terms, we do something called factoring by grouping, and that looks kind of crazy. We'll go over that here in a second. If it only has 2 terms, we do these different methods over here on the left side, and those will make a lot more sense here in a little bit. But those are called differences of squares, and we've actually already learned that before a little bit. So for example, if you had x squared minus 9. Well, that's 2 things being squared. We know that x is being squared, and obviously 9, the number 9 is 3 being squared. And the sign in the middle we call a difference. So a difference of 2 perfect squares is what that means. So another way to think of this is x squared plus 0x's minus 9. And we could just think of this as a normal A times C bottoms up with a trinomial with 3 terms with 0 in the middle. So if I'm trying to find the factors of negative 9 that add up to 0, well, that would be 3 and negative 3. So my factors break apart into x plus 3 and x minus 3. So you've kind of actually already learned that before with bottoms up. So when you see that on your flow chart, that's what that difference of squares is, but we'll do more of that later. Okay, right now I want to teach you factoring by grouping. And notice we use this method of factoring when we have 1, 2, 3, 4 different terms. And this here you'll see on your flow chart. And if you need to pause at any time, go ahead and do that. If you need to go get your flow chart, or if I'm going too fast, just pause the video and kind of get things back together. But this here over on the right side should be on your flow chart. So what this means, so this is called kind of the skeleton. We start out with some polynomial that has 4 terms. And sometimes there'll be x squared, sometimes there'll be x's, sometimes there'll be constants, but for the most part it'll have this format. And what we do is we divide it in half. We always divide it in half. So right now I'm just looking at the first half. And what do you notice both terms have in common? In other words, what's the greatest common factor of the first half? Well, they both have an a. So I can factor or undistribute that a out of the first half. And that would leave me with just x plus c if you undistribute the a back out front. Now we look at the second half. And notice both of those have a b. So we can factor out, in this case it's positive, but it could be negative. We factor out that b, or undistribute, and that leaves x plus c. Now we basically have 2 chunks of stuff. We have this term, and notice that's a times x plus c, that's a term, plus we have this second term. What do both of those blue terms have in common? Well, they both have an x plus c. So just like at the very beginning when both of these had an a, so therefore we could factor out an a, well, now we're at a point where both of these terms have an x plus c. So we can, it's like a giant GCF. We can factor that x plus c out front. And notice if you take that x plus c away from each of them, you're left with a plus b. And you can see that's how it ends. So let's do an actual example with some numbers. That's called the skeleton. That's the format of it. So if you ever get confused or you don't remember what to do, that's on your flow chart. But let's do one with real numbers now. So look at number 1. This is obviously 4 terms. We would factor by grouping. So we always split it in half first. So split it in half. And what do you notice what does the first half have as a GCF? Well, you might see that they both have an x squared. They both have at least x squared. So I can take that out of both of them. And if you take an x squared away from both of these terms, then you'd be left with an x minus 4. Okay, now we look at the second half. It's kind of like we're treating it as 2 separate problems. The second half, 3 and 12, both divide by 3. So if I factor out a 3, I would be left with x minus 4. Remember, by factoring out the GCF, you're undistributing or unmultiplying. So you divide that 12 by 3. So in other words, if you were to distribute this back through, you'd be back to where you came from. So now notice, in this case, our x plus c is both of these x minus 4s. See how they match? There will always be one that matches if this works. So that x minus 4 gets factored out front. And then if I take that away from both terms, we're left with x squared plus 3. That's what goes in your other parentheses. Now in this case, 3 is a prime number. It does not break apart any further. So we are done factoring. That would be your answer. Okay. Number 2, go ahead and pause the video and see if you can do number 2 on your own. The same process, split it in half, factor out the GCF of each side, see if you can do number 2 on your own, and then play the video and see if you get the answer correct. All right, hopefully you were able to work on this problem. So if we split it in half here, both of the first terms have an x squared. And if I factor out an x squared, I'd be left with x plus 5. Now notice both of the next terms they're both negative. So I could factor out a negative 2. And by doing that, by factoring out a negative, you're going to make both of these positive. And we know they needed to be positive because we know that these have to match. So that was kind of a hint that you needed to also factor out the negative sign as well. So now that those x plus 5s match, we bring that out front. And what's left behind is x squared minus 2. And once again, 2 is a prime number. 2 does not break apart any further than 2 and 1. So that does not break apart any further. That would be your answer. The only way that this would break apart is if that had been a perfect square. So for example, if this was x squared minus 9, and we know that 9 is a perfect square. So just like I talked about before, that could be thought of as x squared plus 0, x is minus 9, which we know the factors of negative 9 add up, or 3 and negative 3 would be the two ones that add up to 0 there. So that only breaks apart if that constant number is a perfect square, like 4, 9, 16, 25. Otherwise, that's our final answer right there. All right, here's an extra bonus question. This one's not going to be on your notes. Once again, I would like for you to pause this and give it a try. There's something a little bit weird in this that I want you to see if you can figure out before you watch. So pause the video, give it a try, factor by grouping, and then play the video and see what you get. All right, so hopefully you paused it and worked on this and aren't just watching me do it. Remember, the best way to learn is to, make a mistake or not understand how to do something and then realize, oh, okay, that's what I should have done. So that next time you realize it when you come across it. So make sure you give this a try before watching me do it. So the first half here, notice both terms are divisible by 4x squared. So if I factor out the 4 and an x squared, that would leave behind x minus 1. Sorry, let me go back here, x minus 1. So if you 4 divided by 4 cancels out, and then the 4x squared, I factor out a 4x squared. We have to have the 1 there because some people just want to put a 0 here, but that's not right. If I distributed this back through and there was a 0 there, we would never get that term again. So there is a 1 there. Okay. Now, notice the second half doesn't have a GCF. And this already matches this, so it's kind of weird. So if we just write it out, I'm going to write it like this, but I'm going to put it in parentheses, so plus. You kind of see what's happening here. Really, if there's nothing to factor out, you could say it has a GCF of 1, so it's kind of like there's a 1 there. And you kind of need to see that 1 to realize the second binomial. So you can see that these already match from the very beginning. So those factor out front just like they have before. But if you didn't realize that there was a 1 there, you wouldn't understand what to put in the second binomial. So now you can see that that should be 4x squared plus 1. There is that 1 there that's in between the x minus 1s. Now, technically, this part can factor again, and you're going to get to this later. But notice 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. 1 is a perfect square, 1 times 1. This is called a sum of perfect squares, and it's actually on your flow chart. So if you look over at your flow chart, you'll kind of see, you get a preview to what we're going to learn in a little bit. But this actually factors apart into 2x plus 1i times 2x minus 1i. But you will get to that on the next page in the next video. All right, that is all for factoring by grouping.